Okay, we're going to talk about accuracy and precision. Accuracy versus precision. Now, precision relates to the degree of reproducibility or uncertainty of the measurement. It also refers to how close or how, I guess, exact you can get that measurement, how many decimal places you can go out. So if you have a sundial obviously is not as precise as maybe a watch with hands, which is not as precise as a digital watch that can go down to seconds, which is not as precise as, say, a stopwatch that can go down to milliseconds, okay? So the further you can go down in the decimal range, so if you can go however many places past the decimal, that's a measurement's more precise each decimal place you add. Now, accuracy of the measurement refers to how close the measurement is to the true value. So if you weigh something and your scale can be the most precise scale, you could get 4.57639 grams when it actually weighs 10 grams, 10 point something grams. Your scale may be precise but not accurate. Okay, so accuracy is how close that measurement is to the very true value. Now, the next couple slides, I'm going to show you some pictures of darts, since I play darts on Mondays, just so you can see the difference between accuracy and precision. Okay, so in this one, you've got your red darts on the sides and your blue darts. They're just all over the place, okay? So these darts are neither precise nor accurate. Accurate would be the bullseye, and precise would be in one general location. This kind of looks like how I shoot sometimes. Okay, with this slide, this picture is precise but not accurate. They're all in one number, but they didn't hit the bullseye. So unless you were actually aiming for that number, which if you're playing cricket, you will be, most people, when they aim for the bullseye, they usually get them in one general location because you throw a certain way. So like I'm more precise than I am accurate. I don't hit the bullseye very often. I do on occasion, but usually I jumble my darts in one general location. Then I kind of have to figure it out from there. But so I'm more precise than I am accurate. Okay, and here's our last example. This is both precise and accurate. You get all of the darts into the center. Now, darts, because there's more than one dart, anytime there's more than one measurement, you're going to be either accurate and precise or precise but not accurate. Rarely are you accurate but not precise. That means you got stuff all over the place and only one accurate measurement. They would actually consider that neither accurate nor precise except for in one instance. So, if you have just one measurement, though, that measurement can be both accurate and precise if it goes way down in the decimal range. Okay, so that's the difference between the two. Okay, so rounding numbers. Basically, when you're dealing with accuracy and precision, you're rounding numbers. So usually in chemistry, we need to round numbers based on the significance of a measurement. Also based on the precision of the instrument. So so we'll write that down. So it's based on the precision of the measurement of the instrument. Sorry. Okay, I can't write today. Come on, get the eraser. Oh well, my eraser doesn't seem to want to work today. There we go. So that's the word I'm trying to write on here is instrument. Okay, so like if you have a ruler, you can pretty much go into millimeters and maybe take a wild guess in between millimeters. But if there are rulers that actually can go past millimeters that go into microns. So that's a more precise. So you would be rounding numbers beyond 1 or 2 digits past the decimal because that instrument is much more precise than just a regular ruler. So that's what it's based on. So we round numbers either up or down according to the digit after the place we want to round to. So let's look at 12.5. Was it 12.568? So we want to round that number to 2 places past the decimal. So I'm going to do the whole number. So that's 2 places past the decimal. But we need to look at the number 3 places past the decimal in order to tell whether we round it up or down. So that 6 will either stay as 6 or go to 7. Well, because that's an 8, your answer is going to be 12.57. It's got to go up 1. And I know you guys learned this in middle school and probably elementary school, but I just want to make sure, because I noticed the last couple of times when we were doing some of the lessons or the warm-ups, people were having trouble rounding properly. So I just want to make sure you guys can round properly. Okay, so we're going to round 1.0056 to 2 places past the decimal. So as I said, my little trick is to actually outline the whole number to the point that you want. So it's going to be 1.00 or 1.01 depending. And then we're going to look at this 5. Well, 5 tells me to round up. So my answer is going to be 1.01. Okay, so I had to round it up because of that 5. Hopefully that makes sense. Okay, we're going to round 0.819 to the nearest whole number. Well, guys, that's that 0. That's the nearest whole number. So this 8 tells me I got it's. Now, if that had another number, like let's say that was a 4.8, we could round it to 5. But since it's a 0, we actually have to make that a 1. Now, what if this was 0.419, rounding to the nearest whole number? Well, at this point, you'd still be looking at that one, and that would tell you. So your answer would be 0. So it's just 0 because it's too small. So if I only can go to the nearest whole number and I got 0.419, my measurement's too small to actually record anything but a 0. Okay, so this one's a little hard too. This one's kind of difficult too. We're going to round 1,548 to hundreds place. Okay, well, this is the ones place, this is the tens place, and this is the hundreds place. So I'm going to rewrite the number down, 48.3, and I'm just going to go to here. So this tells me whether to round up or down. Well, I don't round, but 15 is not the same. It's not as big as 1,548. So we have to put 2 zeros in to tell whoever's looking at this that it's 1,500. It's not 15, it's 1,500. Because if you actually say the number in words, it's 1,548. Well, that's less than 1,550, so it's about 1,500. Now, we can do another one. Let's say we wanted to round 1,548.3 to tens. Okay, to the tens place. This, we're going to go to tens, so that's this part right here, and this tells me to round up, so it's 155. Now, it is tens place, so I have to add the 0 to mark that it's 1,550, not 155. Those are two totally different numbers. Okay, so I hope this makes sense because you'll be doing a little bit of this later on down where I say round, to tens place or round to the hundreds place. You have to be able to do that. So you always stick zeros. Those are your placeholders. Okay, so we stick zeros in the number we knocked off if it's in front of the decimal. Now, if it's after the decimal, we just knock it off. It just disappears. But if it's in front of that decimal point, you can't do, as I said, 155 is not the same as 1,550. Okay, hopefully this makes sense, and we'll do a warm-up tomorrow morning and do some practice problems from there. Okay, bye.